First and foremost, I would highly encourage you to pause the video right now and try these 5 problems as if it was your warm-up. You're going to find a whole lot about what you know and what you don't know by doing these on your own and then watching me work through them versus just watching me work through them. You're not, honestly, if you don't try these, you're not going to get a ton out of this video. So I'd pause it, try them, and then you'll see me work through them. Okay. So I'm going to work through these 5. Hopefully you had a chance, and we'll kind of see how you did. I'm going to start with number 1 here. So last class we talked about these log properties, and at the time I just told you here are the properties, here's how they work, but here's really the use for them. I mean, there's multiple uses, but here's the main one. I need to, first of all, evaluate the first 2 without a calculator. Remember what that means to evaluate. It means in the end, I want my final answer to be just a number, like 2 or 1/2 or -3, but basically the log is gone. Well, I don't know what log base 3 of 4 is without a calculator. I don't know 3 to what power is 4, and I don't know 3 to what power is 18, and I don't know 3 to what power is 8. Bottom line, I don't know what any of these 3 values are. But when I use my log properties, remember if you're adding 2 logs with the same base, you could merge them into 1 log with that base and multiply the arguments together. 4 times 18 is going to be 72. Then remember when you're subtracting a log of that same base, that's like dividing by this argument. So essentially we're multiplying 4 and 18 and then dividing by 8. But all that work is done within the argument. Then I can simplify 72 over 8 to log base 3 of 9. And now I do know what log base 3 of 9 is. Because remember, this is saying 3 to what power is 9, and that's 2. So the answer to this question would be 2. One of the biggest mistakes students make is not so much not knowing the properties, but when they combine logs, a lot of times they'll drop the log out. Like they'll say, okay, I know to multiply 4 and 18 and then divide by 8, and then they'll just do 72 over 8 and say the answer is 9. They'll forget to keep the log base. When you're merging or condensing these, make sure you keep the log base as part of the problem, okay? Number 2 is very similar. In fact, it's the same exact type of problem, but I added a couple wrinkles. I added a 1/3 out in front, and I have a 5 in front of this logarithm inside the parentheses. So first of all, I don't know what, again, any of these 3 logs are. All right, well, if I'm trying to evaluate, the first thing I'm going to do is take any numbers in front of logs, like this 5 right here. And remember, if you have a number in front of a log, you can pop it back up as an exponent. When you have numbers in front of logs, you could put them up as powers. And vice versa, if you have powers, you could pull them out in front of the log. So the first thing I'm going to do is put the 5 up on the 2, and now I'm essentially doing 2 to the 5th power right there. And 2 to the 5th is 32. All right, so here's where I got. I haven't done anything with the logs yet, but all I've done is take the 5 and put it up as a power. But now, inside the parentheses is the same thing I had in number 1. I can combine all these logs first. So I would multiply 10 and 32, because we're adding those logs, and then I would divide by 5. So 10 times 32 is 320, divided by 5 is 64. But I have to keep the log base. Now I do know what log base 4 of 64 is. This is saying 4 to what power is 64, and that's 3. This whole expression is 3. So we have basically 1/3 times 3, which is 1. All right, when we're expanding, well, now we're just kind of going in the opposite direction. First thing I want to do is split this up and use my properties. So since the top 2 are being multiplied, I'm going to split that up into addition. Notice how I write that. I just keep the natural log, and I split that up into addition. And then we're dividing by 6, so minus natural log of 6. But I have to keep the natural log on all 3. In the last step, we can't have exponents within the logs when we're expanding, so take the powers and pull them out in front. And that's our answer. We expanded. We have no powers within the logs. and we only have one thing inside of each log. That's kind of the goal. All right. Next two, we're solving log equations. So we've done problems where if you have the same log base on both sides, you just set the arguments equal to each other. The problem on this one, we have this 1/2 in front of this log right here. So just like going back to example 2, when we had that number in front of the log, we're going to put this 1/2 up as a power. So I'm going to write this as log base 3 of 36 to the 1/2 power. Now that I have the same log base on both sides, I know that 36 to the 1/2 and x have to be equal to each other. The reason I picked this one is because a lot of people would look at 36 to the 1/2 and think it's 18. But it's not 18 because remember, taking something to the 1/2 power means square rooting that thing. So this is really the square root of 36. So 6 equals x. But I wanted to do this one to remind you guys it's not 18, but it means square root. The next one is not one that we have done yet. It's when we have multiple logs on one side of the equal sign. So here's the thing. The only time you could ignore the log base on both sides and set the arguments equal is if there's only one log on each side of the equal sign. I can't go into example 5 and just ignore all the log base 2's. It's not allowed. So anytime we're solving a log equation and we have more than one log on one side of the equal sign, step 1 always has to be condense this first. Combine this into one log first. So since we're adding, this would be log base 2 of 5x, because we would multiply x and 5 together, equals log base 2 of 2x plus 1. Now I have my goal accomplished. I have the same log base on both sides, just one of them, so set the arguments equal at this point. And now I just solve this equation for my answer. Subtract 2x, divide by 3. Remember, log equations are equations that you have to check your answer in the end. Essentially, what you're looking for is, if I plug this back in to any of my log expressions, do I get any negatives inside of them? If you do, then you can't count them. But 1/3, if I plug 1/3 in for these x's, I get positive numbers, so we're all good. All right. So good luck on your quiz. Hopefully it goes well.